Okay. The other one was, we all know that time quantums are our secret superpower. Our goal is to not make it so secret, so that it's like a widely known superpower, and then everyone uses them. So, so we want to implement some of the semantics around supporting inserts to time quantum fields. So I'm actually going to spend a little bit more time on this one. So I'm going to create a table, TQ test, which has 2 time quantum columns in it. And you'll notice actually, these are not highlighted yet correctly, but there are 2 new types. So previously, time quantum was a storage modifier. So you would say something like, I want this TQ column, time quantum column, I want it to be a string set, and I want to put a time quantum on it, and then optionally a time to live and all that stuff. We've promoted time quantum columns to prime data types. So there's now a string set Q and an ID set Q, which stand for string set quantum and ID set quantum. And then the same, and then this just says what the granularity of the view is underneath, right? So we've created that, and if I do a show columns, you'll notice we have a new type, and one's keyed and one's not, as you'd expect. And if I do a select from that, we get 0 rows. So say I wanted to insert some values into this. So you can remember that SQL 3 is strongly typed. So in this particular SQL statement, I'm inserting an ID, an int, the string set Q and the ID set Q types. And here, so when we run this values thing in an insert, or a bulk insert for that matter, we're effectively doing an assignment. Go assign the value of 1 into this column in this table. And so what happens when that occurs is there's a type check that's done. So if I had something like foo in here, it would say, no, you can't stick a string into an ID. That's not allowed. So that happens. The other thing that happens is a thing we call type assignment compatibility. So there are some things that are assignment compatible. So in this particular case, we're saying a string set, which is what that expression is there, is assignment compatible with a string set Q. And it's the reason that we can make it assignment compatible is that a string set Q, a time quantum, is a tuple made up of a timestamp and a set value, and then also an implied key. But ignore that bit for now. So what happens is that when we run this insert, what it's effectively doing is it's saying, go stick the value of this set, go intersect this set with the set that's already there, if it's already there, and use the current timestamp, the time I ran this query. So if I run that, it'll go and run, and if I do a select, you'll notice that I get back my set of 1 items. Right? That makes sense. So how do I insert a time quantum with an actual time? Like, so I want to say on this day or in this date or the timestamp, here was the set values. So the way you would do that is we're introducing what we're calling a tuple type. So this is, you can't create a table with a tuple type column, but it's an internal language type. And in the literal form, it looks like that: curly braces and n values. And they are also type checked. So we know that a tuple for a time quantum value, which is, like I said before, a timestamp and a set value, looks like that: timestamp and set value. So same deal, assignment rules apply for the timestamp. What Venkat showed before is there's a number that's going to get treated as seconds. There's some strings they're going to get treated as timestamps. But now what I can do is, instead of inserting just that set and having it implicitly use the current timestamp, now I can explicitly say, use that timestamp or use that timestamp. So if I run this, it's going to insert. And if I run that, it's going to insert. If I run that, it's going to work. And then same deal. If I do a select, you'll notice I get what I expect. Here's all the set values. And because it's reading out of the default view, I get all of them. So that was the scope of the ticket that got done last sprint, which was basically insert into time quantum values. Bulk insert already supports this implicit method. We do need to do a little bit of work to support explicit. So I'm working on that right now. And here's some spoilers. What if, so I got the data in, now I want to get the data back out again. So how do I do that? So we were actually planning on doing this. So we would model being able to select out of a time quantum column as a subtable that basically had, so the way that would work is the subtable function is a table valued function that pivots the column into effectively modeled as a series of tuples. And if you can think of it as a subtable of ID, timestamp, and set value. And then what we could do is then you could express that as columns on a table, right? And then use a join. And what would happen is the optimizer would rewrite this whole mess into the P call graph to go do the time quantum thing. Here's the problem. I think this is still an option for the future. It's the right way to do it. But we need to do some work deeper in the storage engine to make it viable, because once I started doing the rewrite code, I don't know about you all, but I kept writing like 600 lines of spaghetti and then going, yeah, I'm not happy with that. And then go write another 600 lines of spaghetti and go, no, still not happy with that. And then I went on vacay for a week and tried not to think about it. So anyway, and then when I came back, I said, you know what? Let's stop doing the hard way. We'll come back to it later. So introducing, as well as tuple types, a new function called range Q or range quantum. So time quantum, type, and a from and a to timestamp. If you're familiar with the P-equal rows, that's what this is basically. So it's a scalar function that allows us to express range filters on time quantum columns, and you use it like this. Similar to what we do today with set contains functions. So give me the ID, give me the set value from the TQ test table, where it's everything from starting at that value forward. And if I run this, I get the data that I expect to get. And you can see it's a subset of that query. And you'll notice that if you look at the plan for this, down here in the P-equal table scan, you'll see a thing here, time quantum filters. So it will also support multiple. And this bit should be in a PR, hopefully by the end of today. I'm just doing the tests now. And that's my demo. Any questions?